Good afternoon. Today we discuss the velocity versus time graphs. Our last video was focused on position versus time graphs. So let's look at one. Right here we have on our y-axis velocity, and on the x-axis we have time. So time is still going to be sort of the independent variable in this. As time goes by, what is happening with respect to velocity. And how does it look? Let's take a look at this motion diagram to start off with. We've got position 0, 10, 20, 30, time 0, 1, 2, 3. We're not really speeding up here. When we looked at position time graphs, if we were to graph that out, we could find out the velocity of this car by figuring out the slope. And we did something like that in the last video. But let's plot this same information on a velocity versus time graph. Now, we just said the slope of this is going to be, I covered 10 meters in 1 second, so that's my speed. If I plot that on this graph here, here's my value for 10 meters per second. But as time goes by, the velocity isn't changing. Sure, my position is changing, but I haven't changed speed at all. So what we have here is a graph. It's just a flat line, and that tells us something. It tells us that the object is moving at a constant velocity versus a changing velocity. Really important concept. Changing velocity means acceleration. Constant velocity means acceleration equals 0. So I can say that I am moving in the positive y dimension, and I am not changing speed, and that's about it. Let's take a look at this next one. Here we have a motion diagram where we're speeding up. I'm covering a bigger distance in the same amount of time. So we know from our lab last week and from the previous video, hopefully, that this motion diagram is showing an accelerating object. And if we were to show that on a velocity versus time graph, well, we need to know what's the velocity in this position right here. So I want you to notice here that on this sloped line of our velocity versus time graph, that when we hit 1 second, we come up to the line, our velocity is 4 meters per second. Where did that value come from this motion diagram? I don't see 4 meters per second anywhere. I see, the time, one, that makes sense. My position, if I did distance divided by time, 2 meters divided by 1 second, or 2 meters per second, that's not my velocity at this point. Now, let me explain why. So to understand what's going on here, I've redrawn this velocity versus time graph, and the line that's with a positive constant slope to illustrate what I want to talk about here. If we go back to position versus time graphs, like this, and we talked about how, okay, here's my line that I create, and the slope of that line represents the velocity. Okay, if my slope were steeper, it means I'm going faster. If my slope were less steep, it means I'm going slower. So what does the slope mean on this velocity versus time graph? Well, slope is rise over run. And on my y-axis, my rise, I've got velocity, and on the x-axis I have time. So what I'm calculating here is the change in velocity divided by the change in time. And if we come back up here, that's the equation for the acceleration of an object. And so what this slope is telling us is the value of the acceleration, or how fast is the velocity changing. Pedal to the metal. Grandma's driving. Got it? I hope. Let's go back to the other graphic here. So if we look at this graph and we want to calculate the slope of the line, we take the rise, 20, divided by the run, which is 5. 20 divided by 5 is 4. And so my slope of this line is 4 meters per second, or we might just say meters per second squared. And what does that mean? Well, my acceleration, if it's 4 meters per second, it means after the first second, my velocity is going to be 4 meters per second. After the next second, I'm going to add another 4 meters per second. After the next second, I'm going to be going 4 meters per second faster. So you can see how we're adding 4 meters per second after every second that is elapsed. And so, to figure out the slope of this line, take rise divided by run, and that tells you the acceleration. Another thing I want to point out looking at this picture here is this slope doesn't curve at all. So that's going to tell you that the acceleration value is constant. Let's take a look at these two. Here we have a velocity versus time graph. Time is going by, but my velocity is not changing. Okay, we've got a positive velocity. We're not in the negative dimension down here. But the line is flat. There's no slope. So if we have no slope, we have no acceleration. On this one, here we do have a slope. We have positive velocity, and the acceleration is also positive. But we might throw in one more thing. We might say that this is positive constant acceleration. And is there anything else I want to talk about here? Yeah, let's take a look at this. Okay. Consider the graph at the right. It's pretty small here. We have a velocity versus time graph. The line is straight. It's going down. The object whose motion is represented by this graph is. Include all that is true. Take a minute to think about this. So A was true. The line is in the positive region of the graph. B was false. There is an acceleration. It's changing velocity. There was a slope. It was negative, but there was a slope. False, since it's a negative velocity, it would be a line in the negative region. We weren't in the negative region. D was true, since the line is approaching the zero velocity level. E was false, since the line never crosses the axis. F false, since the line is not moving away from the x-axis. G was false, since the line has a negative or downward slope. And then H was true. So there's a lot of questions that can be asked about velocity versus time graphs or position versus time graphs. And if you want to read more about some of this, I've just scratched the surface of this website. The physics classroom, it's going to be one of my go-tos this year because it's pretty sweet. It's got everything we need to learn about in kind of a virtual classroom format. And something I might have you do in the future are these concept builders and physics interactives. And if you feel like you need a little bit of practice, we can do some position versus time graphing just for fun. Match that graph. So if you want to, you can click on this and you can gain some practice with these position time graphs and also the velocity versus time graphs. And it gives you some directions and a little simulator here that should pop up. And yeah, I think I'm done. Have fun with that. Have a great day. See ya.